Let's talk about how we can formally prove that two triangles are similar by writing a two-column proof. For example, in this proof we're told that AD over AB is equal to AE over AC. Now that's a whole lot of information that you should probably go check out on the diagram so you know what it's actually telling you. AD over AB, so that's this little part over this entire side length. And that's equal to AE, which is this little part, over AC, which is this whole side length. So it's little part over whole thing equals little part over whole thing. Our goal is to prove that the little triangle on top, triangle ADE, is similar to the entire triangle, triangle ABC. Well, we're off to a pretty good start because we already know we have two pairs of corresponding sides that are proportional. In order to prove that the triangles are similar, I need one of two things. Either I need to show that the third pair of sides is also proportional to the first two, or that the included angle between these two sides is congruent. Well, I wasn't given any information on the diagram or in the given about sides DE and BC, so it's looking like proving that this angle is congruent is my best shot. And it's actually pretty easy, because angle A has to be congruent to angle A by the reflexive property. Since this angle is the included angle between sides AD and AE, as well as between sides AB and AC, there's really no work to do to show that angle A is congruent to itself. We just use the reflexive property. So now we have enough information to say that the two triangles are similar by side-angle-side similarity. Since we had two pairs of corresponding sides that were proportional, and we proved that their included angles were congruent, these two triangles must be similar. Our next proof, we're told that DE is parallel to BC. Let's label that on the diagram. And our goal is to again prove that the little triangle is similar to the entire triangle. Well, we weren't told anything about the side lengths of any of these segments, so there's really no way for me to show that I have proportional sides. Instead, I need to be looking for two pairs of corresponding angles that must be congruent. And that's pretty easy to find when you're given parallel lines. Remember from first semester that parallel lines cut by a transversal make all kinds of special pairs of angles. For example, wouldn't this angle and this angle be congruent? Because they're corresponding angles. And that's actually not the only pair of corresponding angles I see in this diagram. You could also say that these two angles are congruent for the same reason. So by the corresponding angles postulate, we have two pairs of corresponding angles that are congruent. And that's enough information to say that the triangles are similar by angle-angle similarity. This is not the only way to prove that these two triangles are similar. You might have noticed that angle A is one of the angles in triangle ADE and in triangle ABC. They share angle A. So instead of using the corresponding angles postulate twice, you could have instead used the reflexive property to say that angle A is congruent to angle A. Your final reason would have stayed the same, the angle-angle similarity theorem. Our final proof tells us that angle B and angle D are right angles. So I'll write that down for my first statement, say that it's given, and label my diagram. Our goal is to prove that these two triangles are similar to each other, and knowing that I have right angles doesn't really help me. I need to know that I have congruent angles. Thankfully, we have the right angles congruence theorem, which allows us to say that if two angles are right, then they are congruent. So instead of labeling these as right angles, I'd rather that they were labeled with congruent symbols. So that's one of the two pairs of angles that I need in order to prove that these two triangles are congruent. Do you see any other congruent angles in this diagram? Well, yeah, we have vertical angles. Angle ACB and angle ECD are vertical angles by definition of vertical angles, which means they must be congruent by the vertical angles congruence theorem. So since I have shown that these two triangles have two pairs of corresponding angles that are congruent, I can conclude that they are similar triangles by the angle-angle similarity theorem. And that's all you need to know about how to show that two triangles are similar to each other. In our next lesson, we're going to explore how proportionality can be applied to other parts of similar triangles.